Here comes the question number 19. It goes like this. In a trapezoid ABCD, the sides AB and CD are parallel. The length of the side AB is 4 units and the length of the side CD is 10 units. There are two rays R1 and R2 that intersect each other at right angles. R1 intersects the line AB at point A and the line CD at point D. R2 intersects the line AB at point B and the line CD at point C. If the lines CA and DB are extended, they intersect at point E, making an angle of cot inverse of 20 by 21. The question is, calculate the area of the trapezium ABCD. To start with, I am going to draw a geometric construction of what is given in the question. And I am going to use the rule square page of my iPad to do that. Actually, my iPad might also work like a graph or rather graph sheet. So I can calculate the exact area of the trapezium just by looking at the dimensions of my drawing. But don't worry, I'm not going to cheat. I'm going to derive the area of the trapezium from what is given in the problem. First, let's do a geometry construction. I'm going to draw R1 and R2 that are intersecting at right angles. This is my R1. Okay, and this is my R2. Okay, let me adjust them to be exactly at right angles. Okay. Okay, cool. So this is R1 and another one is R2. Next, what is given? What is given is there are lines AB and CD that are 4 units and 10 units. So I'm going to draw the line AB and CD now. So this is the line AB and this is the line CD. Okay, cool. Now what is given? What is given is if you extend the line CA and DB, it will meet at point E. Let me name the line as AB and CD. Okay. So this is AB and this is CD. Next, I'm going to extend the line CA and DB to meet at a point E. Okay, I'm extending the line CA further to like this, then DB like this. Okay, they are fairly accurate. Let me adjust them a bit. Okay, now next what is given is the angle at E is cot inverse of 20 by 21. If I name this point as E, the angle made at point E is cot inverse of 20 by 21. That is, this angle E is cot inverse of 20 by 21. And AB is 4 units and CD is 10 units. So this is 4. This is 10. So with this information, we have to calculate the area of the trapezium ABCD. What is also given is the line, rather rays R1 and R2 intersect at right angles, like this. Okay, so this is our construction. So based on this, we have to calculate the area of the trapezium ABCD. To start with, I'm going to describe 4 toolkits, or rather 4 elements of my toolkit, which I'm going to describe, which will be useful in this calculation. Let me write that down for you. My first toolkit. If you draw a line intersecting 2 parallel lines, the interior angles are equal. This is a property of a parallel line, correct? So toolkit number 1 is if a line is drawn to intersect the interior angles are equal. Okay. Now, what does it mean? We have A, B, C, D are two parallel lines. Okay. And the ray R1 and R2 intersect these lines A, B, and C, D. Therefore, what are the interior angles here? The angle, okay, let's say R1 and R2 intersect at point O. So, the angle OCD is, let's call this as A. Then angle ADO is the interior angle, corresponding interior angle. That should also be equals A. Similarly, the angle ODC, let's call this as B. If this is so, the angle BAO should also be equals to B because that is the corresponding interior angle. That's what it means. Then toolkit number 2. The formula for the area of a triangle is half multiplied by the base multiplied by the altitude. The area of a triangle is 1/2 multiplied by base multiplied by altitude. I'll explain later the area in terms of our diagram later. Then 3. Tan A plus B formula. Tan A plus B equals tan A plus B equals tan A plus tan B divided by 1 minus tan A tan B. Tan A plus, okay, the last one, fourth one. Fourth one is a little bit abstract. I'm going to define what is an inverse function. The inverse of a function f of x is defined as follows. Okay, it reads like this. The inverse, f inverse of a function f of x is defined such that f of f inverse of x equals x for every x in the domain of f inverse. Now, the domain of R cot or cot inverse is all real numbers. Okay, so I'm going to use these 4 tools to solve this problem. You may be wondering why I am defining an inverse function. There is a small hint in the problem saying that the angle at point E is cot inverse of 20 by 21. So at some point, you might have to evaluate an inverse function. Okay, let's move on to the solution proper. First, let me label the angles and sides as follows. Angle ACB is angle alpha. Then angle ODB is angle beta. And the angle CED is angle gamma. Okay, now let me mark the length AO as x and OB as y. Next, let OD as x prime. Then let OC as y prime. But don't worry, we will get rid of x prime and y prime and write them in terms of x and y. Okay. Now, let's go to the step 1. Let's look at the triangle COD. Now, COD is a right angle triangle because the angle at O is 90 degrees or rather pi by 2. So, the angles A plus B should be pi by 2, right? Because that's the property of a right angle triangle. Now, let's look at the triangle CED. the triangle CED, the angle at C plus angle at D and angle at E should all add up to pi radians, correct? That's the basic property of a triangle. So alpha plus A plus B plus beta plus gamma should be pi. Now let me put a bracket around A plus B. Because A plus B is pi by 2, we know. So this can be written as alpha plus pi by 2 plus beta equals pi minus gamma, right? Okay, now so we have the expression alpha plus beta plus pi by 2 equals pi minus gamma. So we are going to solve for alpha plus beta. Alpha plus beta would be pi minus pi by 2, which is pi by 2 minus gamma. Let me call this as equation 1. Okay, let's proceed to step number 2. Step number 2. First, the triangle ABO. It is a right angle triangle. Okay, from the right angle triangle ABO, what we can write? X square plus y square equals 4 square, or rather x square plus y square equals 16. Let me call this as equation number 2. Now, in the triangle ABO, what is cos A? Cos A would be y divided by 4, because y is the adjacent side and AB is the hypotenuse, which is equal to 4 units. Okay, then cos B would be x divided by 4. Next, the triangle COD. In triangle COD, the cos A would be y prime divided by 10. Similarly, cos B would be x prime divided by 10. So, if we solve these two set of equations, I will have the expression for x prime and y prime in terms of x and y, correct? Okay, let me call this as equation number 3. Next is step 3. I've just pasted the geometry construction and questions from the earlier page and we are continuing from there on. Okay, now step 3. There are two ways of writing the area of this trapezium. One, half L1 plus L2 multiplied by the height. L1 and L2 are the length of the parallel sides and the height is the perpendicular distance between these two lines. That's one way. The another way is to add up the areas of the triangle ABC and BCD. Okay, so these two are one and the same. We are going to follow the second method, that is, we are going to calculate the areas of the triangle ABC and BCD and add them up. I am going to calculate the area using the later one. That is, I am going to calculate the area of the triangle ABC and BCD and add them up. Okay, so area of the triangle ABC. Let's see what it gives. So this is the area of the triangle ABC. Okay, this is the triangle ABC. Next, area of the triangle BCD. Next, I'm going to write down the formula for the areas of these two triangles. half multiplied by the base. The base is BC, and BC is the common base for both the triangles, correct? Altitude of ABC is the line AO, because AO is perpendicular to line BC. So AO is the altitude of this triangle. Similarly, half BC. BC is the common base for these two triangles. Then altitude of BCD would be DO, because DO is perpendicular to BC. Let's simplify this. BC is a common term, half is also a common term. So I'm going to factor out half multiplied by BC. So half BC multiplied by AO plus DO, correct? Let me write it as OD instead of DO. Okay, now what is BC? BC is y plus y prime, and AO plus OD is x plus x prime. Cool. We already have the values of y and y prime, now the x prime and y prime, right? So equation 3 gives you the values of x prime and y prime in terms of x and y. Let's apply this and solve for the area ABCD. Okay, so we have half y plus 5 by 2 y multiplied by x plus 5 by 2 x. Let's simplify this. Take 2 as common denominator. So you will have 7y by 2 and 7x by 2. So half 7y by 2, 7x by 2. So that gives 49xy by 8. Let me call this as equation number 4. So this is equation 4. Okay, now we just have to calculate xy to calculate the area of the trapezium ABCD. Cool, isn't it? So to calculate xy, we are going to proceed to step 4, and I am going to use the tan A plus B formula. Step 4. I am going to write out the formula for tan alpha plus beta. That will give me tan alpha plus tan beta, the whole thing divided by 1 plus tan alpha tan beta, or rather 1 minus, sorry. So this is the formula for tan alpha plus beta. Tan alpha plus tan beta divided by 1 minus tan alpha tan beta. Now what is tan alpha? So from triangle AOC, tan alpha equals, that is the opposite side by the adjacent side, that is x divided by y prime. Okay, then tan beta, that is the triangle ODB. So tan beta would be y divided by x prime. Okay, we know what is y prime. So that will be x divided by 5 by 2 y. Then tan beta would be y divided by 5 by 2x. So we can write this as 2x by 5y, right? And this would be 2y by 5x. Tan alpha plus beta would be tan alpha, that is 2x divided by 5y plus 2y divided by 5x, the whole thing divided by 1 minus 2x by 5y multiplied by 2y by 5x. We have to simplify this now. So in this expression for tan alpha plus beta, we have 2x over 5y plus 2y over 5x in the numerator. So I can take 25xy as a common denominator, right? You may be wondering, it is 5xy, why 25xy? But I prefer 25xy for some reason. Okay, the first term would be 2x multiplied by 5x, that is 10x squared. And the second term 10y squared. The whole thing divided by, now since x and y have cancelled each other, we have 1 minus 4 divided by 25. So take 25 as common denominator and simplify this to 25 minus 4 divided by 25, that is 21 divided by 25. So this can be written as, okay, in the numerator I can factor out 10 and write it as 10x squared plus y squared. We have 21 over 25 in the denominator, so we can multiply this whole thing with the reciprocal, that is 25 over 21, correct? Okay, now this 25 gets cancelled. Okay, x square plus y square is 16 from equation 1. So 10 multiplied by 16, the whole thing divided by 21xy. Okay, now we have tan alpha plus beta. Alpha plus beta is pi by 2 minus gamma. So tan alpha plus beta equals tan pi by 2 minus gamma, which is nothing but cot gamma. So that is the complementary angle formula for tan. So cot gamma is 10 multiplied by 16 divided by 21xy. So which gives xy equals 10 multiplied by 16, the whole thing divided by 21 multiplied by cot gamma. Okay, so we have the final expression for xy. We just have to supply the value of cot gamma, solve for xy, put it in the other equation for area of the trapezium and arrive at our final answer. Now, xy equals 10 multiplied by 16, the whole thing divided by 21 multiplied by cot. Gamma is cot inverse of 20 by 21. Okay, now you understand why we define the inverse function. Because we have the expression here, cot inverse of 20 by 21. What is cot inverse of 20 by 21? As per our definition of an inverse function, it is just 20 by 21. Okay, and 20 by 21 is in the domain of cot inverse, and 20 by 21 is a real number. Okay, here 21 gets cancelled. Then we simplify. 10 by 20 will give 2 in the denominator, and 16 by 2 will give 8. So our xy equals 8. Therefore, area of the trapezoid ABCD is 49 divided by 8 into xy equals 49 divided by 8 into 8 equals 49. So that's my final answer. Let me box it. Okay, there it is, our final answer. Now, you may be wondering, since I have done the drawing to exactly as per scale, because I've used this notebook as a graph paper. So let's look at the trapezium and see whether we can write down the area just by looking at the graph. Here it is. This is our trapezium. It is to the scale because I have used this as a graph paper. So if you count out the height, value of height is 1, 2, 3, 4, 5, 6, 7. There are 7 squares in the height. So the h would be 7. Therefore, the area of the trapezium would be half multiplied by 10 plus 4 multiplied by 7. 10 plus 4 is 14. 14 multiplied by half is 7. 7 multiplied by 7 is 49. Cool, isn't it? So that's the power of drawing, making a drawing to the scale using your graph. Okay, let's move on to question number 20.